Hello there, I'm Dr. Teddy, MD, PhD, MBA, the third, twice removed by the way. Today, we're going to talk about the nuclear magnetic resonance spectroscopy, or NMR, and how it relates to the magnetic resonance imaging, aka the MRI. A brief history of the NMR is that it was first used in the Humble Oil Company to study protons in anodes. But now that we have huge magnets and machines that recognize proteins in a 900,000 Dalton range, we are able to manipulate the properties of the NMR and apply it to the MRI. Now on to Mr. Bear, DO, I'm better by the way, who will better explain the components of the NMR.
Right. Thank you from my colleague, the overqualified, very pompous Dr. Teddy. The best way to understand how an NMR or MRI works is to understand the atom at its most basic level. First things first, we must know what an atom consists of. The atom has two major components, the nucleus and the electron cloud. The nucleus is a positively charged center of the atom. It has a spin of zero. This, coupled with a charge, causes a dipole moment or an object with poles, i.e. positive and negative, similar to a magnet. These poles interact with the magnetic field. Now on to Dr. Pumpkinky to talk about how this relates to spectroscopy.
Hello, my name is Dr. Pumpkinky from the DeVry Institute of North Dakota. My friend here, Frankie the Big Bass. Say hello, Frankie. And we are going to talk about the MRI machine, in particular its magnet. The MRI machine has a large board design with a magnetic field strength of 0.8 to 3 Tesla, which is stronger than the magnetic field strength of the Earth, which is around 10 to 5 microtesla.
Whoa!
This is nothing compared to the strength of an NMR magnet, which is 10 to 25 Tesla. The MRI machine contains a gradient magnet that superimposes a magnetic field on the body in 3 perpendicular directions. The body itself is made up of water and fat, so protons are plentiful. When the magnet is turned on, the protons align with the magnetic field and the radio frequency pulse is applied, which then aligns any protons that did not align. Okay. Alright. When the magnet is turned off, protons that change direction release energy, which is then measured and translated into an image through a complex mathematical equation known as the Fourier transform. Now we will demonstrate how an NMR machine works with our friend Schrödinger cat.
Now on to the experiment, I mean the procedure with the MRI. And there you have it, the MRI of Schrödinger cat.